I am Matteo Collina. You probably have seen me this morning. I hope you enjoyed the keynote. Yeah, I came to this conference to deliver this talk. And it's about taking your HTTP server to ludicrous speed. So I have a question for all of you. How many of you have watched Spaceballs? The rest go to Netflix or somewhere else and watch this movie. Probably one of the best movies of all time. So you should really go and watch that movie. Okay? And in fact, the key point of the talk is that light speed is too slow, and we need to go right to ludicrous speed. This talk is not about Spaceball. So we forget about that. And we start talking a little bit about how can we make our HTTP server, our application, faster. Last year, my colleague David Mark Clemens and myself started working on this tool called 0x. It's a tool for doing flamegraphs. What is a flamegraph? Another slide first. We also wrote another tool called AutoCannon, which is an HTTP 1.1 benchmarker. So you can just generate a ton of load to your machines, and it's all written in Node. And you can script it with JavaScript. Why do I have to use Lua to script my benchmarking tool? And so I wrote one in JavaScript. It's fast, and it can generate as much load as WRK or AB. So more or less, it just leverages the libuv stuff internally. This is a demo about how 0x work. You launch 0x and your file. Then you launch AutoCannon. AutoCannon sends some data. This video has been sped up twice. So AutoCannon generates some nice stats. Then we generate a flame graph. And as we can see, we have a flame graph represents the call stack. So you have your application. That's every function call in your application. It's been represented over time. It's collected over time and represented. And you see in a darker red color. Hopefully you can see this. We changed the color scheme because in the previous projectors, the previous color scheme could not really be understood on how to use the tool. And the darker is the hot path in your code. So it tells you where the bottleneck is and where your application is spending most of the time. We are going to see a lot of examples of this in this talk. So I'm not spending too much time on this slide. So we will go forward and see more. There's all the documentation in 0x, so npm.js.org, search 0x, and you'll find the tool. So let's go back to the original point, which was about taking your HTTP server to ludicrous speed. So a lot of you might have written something similar, okay? Using just bare metal node core, no framework, no nothing, okay? We just set some headers. Application JSON, yes, we are returning JSON, right? I hope you don't return XML anymore. So. And we call in this, and we define an handle function, and in this handle function, we call JSON stringify on a JavaScript object. Very typical, right? Well, most of you probably wouldn't have written this. Most of you would have written something similar with Express or Hapi or Restify. Just a big question, how many of you use Express? Okay, most people. Hapi? We are huge fans of Hapi at nearForm, okay? Yeah. Restify? The rest. Fantastic. Hey, that's a good start, so I will treasure that. By the way, in Express, if you want to get some good performance out of Express, you need to do those two disable sentence, especially the ETAG one. It's super costly. So if you're running Express, disable that ETAG. Otherwise, you will spend a lot of time doing crypto stuff. Okay? That's a trick that my friend Doug pinged me. So, that's there. So let's see how those two compare in performance, okay? How do we measure performance? We just run AutoCannon, and we get some numbers out of it. Now, I got this number this week using on a M4 extra large instance on AWS using Node 8.6.0 with the new turbofan and V8 6.1, whatever, the best, the latest and the greatest of Node. And you can see that Node Core is ticking at more or less 40,000 requests per second on such a big box. It's a lot, okay? A lot of requests per second. And Express, that server that I showed, does 21,000, which is still pretty good, like super fast, let's be frank. But we are losing some throughput there. So where did it go? That's the question. So what we can do is we can use a flame graph to see where it can go. So let's first start analyzing a flame graph of Node Core. And this is the server that I showed you before and a flame graph. So we can see one thing that strikes super hot are these two things, okay? So this is the base of the flame graph. And you see that, well, Node is really, really hot. Yeah, fine, okay. That's expected, hopefully. However, at the top, so the thing we are interested in, the thing at the top. So if we click, we see that, this libsystem kernel write v, it's 12% at the top of the stack, okay? Which means it's, 0x collects a lot of stats data using dtrace or perf, depending if you are on Mac or Linux, and it samples your application every millisecond, and based on that data, it plots it, and it computes, it sums up all these stacks, and shows, well, this function has been running 12% of the time. The second one is socket write generic from Node Core, okay? Again, we are writing stuff to a socket. An HTTP server is basically a net server. And, we are writing stuff to a socket. So most of our application is spending time either in write generic or write v. Fantastic, good job, okay? That's great. The other bit that is very interesting is this one. So this is Node Core, okay? This tower here, it's Node Core. This flame here is Node Core. Now, this little thing, it's our application. Now, we can see it by clicking on handle. And we can see that this file, bear.js, is my file. And this is, says it's 5% at the top of the stack. Where that comes from? It comes from JSON stringify. JSON stringify, it's a very intensive CPU-bound operation. So generating that thing takes some time. Specifically, 5% of the time of our sample, it's spent running JSON stringify. Okay, plus some other bits and pieces, but the other bits, but those are not really interesting, okay? Still, Node Core stuff. So, by the way, in 0x, it's very easy because we can remove Node Core, and it will tell you exactly where your thing is. So you see the handle here, and write generic, because that's the native C bits. So, yeah, here we go. So we just removed all of it, and it's just this function. This is our application, right? That's the only thing you're doing. Not a very complex one, okay? I've run this in very much complex application, a big thing. So let's go back to the slides. And then we run the one with Express. And this is what Express does, okay? And you can see the difference. You can see the different shape. And, we have still write generic and libsystem here, which is the Node Core bits, and this, it's our application, including Express, okay? This is, we pass through a lot of steps to get to our code. You can see here that send, it's very hot, okay? When you go to send is very, very hot. It's a very hot function. Yep, that's true. It's part of Express, and it's what we use to send the data, and it's what it does, the JSON stringify bit that we have seen before. So again, we can validate our stuff, removing core. And you see that these are the dependencies, okay? You see these deps here. These are just our dependency plus our application. We can also highlight it with this button, and in blue you will see our dependencies, okay? And this is our application here, the bits. Well, no, this is not it. Anyway, so that's what's happening. So going back to the topic of this talk, how to take your HTTP server to Ludicrous Speed. I started this journey of these experiments on how I can write something that is fast and fast HTTP applications. So, if you want to write something very fast, you start from scratch with the bare minimum thing. You add a feature. You measure. You run your benchmarks. You optimize until there is no overhead left in the thing. You have introduced no delay, no more, you're not lowering your throughput. And then you go to the second point. You add another feature, and you keep going. It's very hard to optimize, to go back then and start optimizing something after the fact, okay? Because your API and your thing can be shaped differently. Now, this is for going ludicrous speed, okay? If you don't want to go ludicrous speed, don't worry about it. So that's a question that I ask myself looking at our numbers. Can we go faster? Can we make the Node Core example faster? Where we were spending time? Well, yeah, we were spending time in doing JSON stringify. Okay, that's where the only thing it was doing. It was calling JSON stringify. So yeah, we were spending time doing JSON stringify. At JSON stringify, if you know how a JSON is structured, it's a recursive data structure. Okay, an object contain an object contain an object. Okay, speed means that the function is kind of recursive. It needs to traverse all this thing. It's hard to optimize. And more importantly, is also a bit of generic code. And it's very hard for it to be type specific. Now, you probably have seen from the talk from this morning from Francisca that V8 recognizes shapes and types, and he likes that. So, yep, that's it. However, we wrote this thing called fast JSON stringify that enabled to double the throughput of JSON stringify. Okay, so how can we write JSON faster than JSON stringify? Well, we use a trick. Okay, it's just a bare old school trick. We cheat badly. It's schema based. So we define the type that we want it to be rendered. So instead of getting a generic data structure, we actually say, well, we are going to render this data structure in this form. So we don't have to do a recursive function anymore. We just need to walk down a certain path. And all of this, if you know a little bit how V8 works, can get inlined in one single binary blob of binary code that can be executed at insane speed by V8. Now, okay, yeah, that's not generic, but there is JSON schema, it's a standard, and we use that to render the stuff. How we do it, we generate code. So we use new function, okay? It's safe, we do it before start, so no user data is coming. If your linting or whatever complain, nope, that's safe. By the way, you shouldn't use new function with production data, okay? You can use it when you boot, that's fine. Production data, new function, not good at all. So this is how you use it. You require fast JSON stringify, you pass in a blob of JSON schema. We support a lot of bits of the spec, not all of it. And then you call the function with your object. Okay, specifying the type, okay? There is a lot of interest about this typed JavaScript type of thing, so I don't want to get too much into that, but, it's type-based. So what it does, this is faster than JSON stringify, and we can get just a tiny bit more of throughput out of it. So we can go at 42,000 requests per second with that server compared to the one in Node Core. Sounds a lot, sounds little, depends, okay? Depends on your application, depends on your need. Most code doesn't need to go ludicrous speed. So it's perfectly fine to write an application that does 10 requests per second if that's your business needs, okay? No, don't laugh, like that's actually true, like, So let's add an HTTP router because, well, that's a single route, so we want to add an HTTP router. So we looked about the alternatives and we wrote this one. My friend Thomas wrote this one called Find My Way. Which completely avoid closures allocations, and that's a bit of a problem for V8 to optimize. Now, probably one of the future versions of V8, 63 maybe, it's going to fix this, but at this point, it's still a problem. And it's built on a data structure that is called a radix tree. It's actually a fantastic data structure, and it is perfect for parsing a URL and mapping it to a function or whatever. And it's very safe to use. This is the difference in performance with the router that you probably know and use. it gets incredibly, because of that data structure and some and the way things are lined out in the code. If you open it up, it works in a gigantic while loop. Probably not the nicest code to read from time to time. If you want to go ludicrous speed, the code you're going to write is going to be probably not nice, okay? But it probably can't be very fast. This is for serving one single static route. So that's what it is. We have similar benchmarks for dynamic, parametric, regular expression, whatever you want. It's supported. This is how you use both at the same time. So we create a router called Find My Way, and we add a none with the method that we want and the path, and we serve our thing. Okay. And with this router, what did happen? This is gone. With this router, we got up to 42,000 requests per second still. We haven't lost a thing. Okay. Why this is happening? Because it gets all magically inlined by V8. So really good. So yeah, after we started tinkering with this type of things, we started, well, maybe I can keep going and write a full framework out of this stuff. Okay, let's see how far we can go. And well, I went to this road, and this is Fastify. It can be used. Okay, it's probably beta quality at this point. There is a couple of people putting it in production. You can try it out. We love the feedback. It's managed and handled by open source type of thingy. So if you contribute, we get you the commit bit. The API is similar to the ones of Express, Hapi, and Restify, putting all together to some extent. It's a little bit the best things of everything, at least from our point of view. You specify your route and you replace the send, but in fact you want to do the specify a schema for your output, okay, to get the best performance out of it. Okay, across a big JSON data structure, this thing can give you between 20 and 30% more throughput just because you specify a schema. Because most of the time you need to sanitize your data anyway before rendering it. So, and doing it in one single step, it saves you a lot of time. So this is Fastify, and Fastify, shorten the gap a little bit, okay? And it's very hard to get higher, I have to say, okay? If the moment you add a framework and you start adding a lot of checks and types and so on, you are going to lose some performance, okay? Even if you optimize that out of everything, you're going to lose some throughput. I have some idea to get higher, but yeah, that's it. So this is a flame graph of Fastify, okay? Yep, you can see that the hottest thing is this write generic, okay? And it's still the super hot path, and it looks a lot like the one of Node Core. In fact, if to go for Fastify, we need to check this type of things. You see, this is handle request, reply, okay? It's very tiny, okay? It's very hard. So this is another one, okay? This is Fastify itself that's sitting there, and this is our handler. Now this is our handler that does some bits. So yep, that's what it is. It's not at all a problem, okay? And we can see it's the handler because it's HR time, yeah, very little things. So anyway, sorry. So what happens? It's and this is what the bare thing is. So this is our self, and this is bare. So there's very little difference in the shape or the form of our frame graph. So good visual feedback about, oh yeah, we're doing something good there. From a feature point of view, we support most of the other bits and pieces. Express is still fantastic. We love Express. It's built on the middleware thing. I also love Hapi a lot. We have big Hapi users. Hapi has a new major release coming that is going to be way faster than this. So good work, good job. So the way Fastify works, it implements all of these features by pre-initializing some very fast data structures so that we can provide very fast access and at runtime. So we don't have to, force do a lot of computation in real time to process your application and the fact that it's nested and other things. It's all pre-compiled to some data structures that provide us extremely fast access, like the router or the fast JSON stringify. Some part of this work is based on the research that I've done for reaching ludicrous speed. It's another talk that I did in Interactive in 2015. What's this one? More or less, I spoke about the closure problem. And the problem with closure, it just to sum it up very quickly, it goes about the fact that when you write a function that want to process some big data, some chunk of data, okay, and you go this nice callback halve thing, you have two main issues here. And the first one is big data, okay? It's alive till the end of the nested closure, the innermost closure. So the garbage collector can't clean the data up. And so it will spend more time because you have more data flying. So it will have more work to do. And the other bit is the functions are very short-lived. So they are very hard to optimize and improve by the runtime. So one trick, you can avoid nested closures. So if you have a for loop or something that is very intensive, you can call another function, okay? You don't have to do anything in nested and inline. You can call another function and have to do that, okay? Also, in this way, big data exits scope when that function ends. So we can avoid keeping it up for some more milliseconds of I/O time. And this is our function that can be optimized. So there is this library that I wrote called Restify. It's a trick. We use it everywhere in Fastify. It's a little tiny library. It's impossible to understand what it does from the README. Okay, trust me. It's unfortunate. Fastify also consumes request, response, next middlewares, like Express does. Connect type of middlewares. We don't do anything on the prototypal bit of Express. And we use it to this library called MIDI. And I hope all of you use Helmet, the ones that uses Express. If you don't know what Helmet is and the Helmet suite does, check it out straight away and put it in your application. It's an almost need if you're doing Express. So I do the same server with the Helmet suite installed. And this is the difference. And we get Express at 15,000 requests per second and Fastify at 20,000. This is what the flame graph that Express does in here. So these are all the middlewares of the Helmet suite, of the Helmet modules. We need to zoom out. Okay, so yeah, there is a lot of work here. Okay, it's very easy to see that there is a lot of work. This is what Fastify do. So this does less work, okay? And by doing less work and avoiding such nested call stack, we can actually optimize a little bit more and be a little bit faster. Comes out that one of the hottest thing is HTTP-outgoing store header. Yep, that's what it happens to be. But still, this thing here, it takes some time. Okay. So we also support validation of incoming data. And we use, again, JSON schema, because one of the best thing about standards is when you have a standard, you can have multiple things, multiple implementers competing on that, implementing that standard. So we use JSON schema for that reason. And we decided to use AJV, which is not the fastest. And you will ask why, if you want to go ludicrous speed, you're not using the fastest one. Because AJV is the most correct in comparison to the spec. Okay? So that's about it. So this was Fastify, and I probably have 5 more minutes. Can you confirm? Yeah, fantastic. Okay. 4, fantastic. So I will go through very quickly with you through a demo. Okay. Well, I'll go to the complete version of the demo. Whoop. And I'm a little bit late. So this is a server that I wrote using Fastify, okay? And in Fastify we can register a plugin, okay? That's what we do. We register plugins, and we can specify, for example, we want Fastify Helmet, we want point of view, which is our rendering engine. We use this demo use Marco. Hey, Marco. And then we register a subsystem, we'll see that in a moment, and a couple of routes. What's a subsystem? Now, a subsystem is actually it's just a function. It's a module that exports a function. And you see here that we support nested register calls. So the plugins are fully encapsulated between each other. And the way we do it, so you can embed chunks of your application and mount them somewhere else. Express does the same thing, is one of the best features of Express. However, Express computes that stuff at runtime, so it costs a lot more. We assemble the full application at startup time, so we can then access the data in an extremely fast way. And we define a couple of routes. Note that here we actually specify the slash, and the reason for the slash is because we mount the plugin at the prefix dash subsystem, so we can export it over there. Okay. So remember that most code doesn't need to go ludicrous speed, so you can walk out this room and forget all of what I said. Okay, it's not needed. Okay, it's needed if you want to write very fast applications. I care a lot about writing very fast applications. It's also part of my job to some extent. But it's perfectly fine to write an application that does 100 requests per second or 50 requests per second. Depends on your business need. Okay, so when you want to write some software, one thing you need to ask is how many users are going to use this thing. Okay. And then write the software accordingly and choose the tools that you want to use accordingly. There is also a nice article about Turbofan. If you want to know, we did a little bit of an experimentation, some checks on the new engine about V8 60, 61, 60, V8 60 and 61. So you should read this. It explains the different performance profile between Node 6 and Node 8. If you are migrating to Node 8, probably you are thinking about moving to Node 8 if you haven't already. Please do. That's a nice one. I will need to do a little bit of acknowledgement. I would like to thank Torsten over there. Thank you for the 0x will not be possible without one of your modules. So that's what it is. Thank you for figuring that piece out. It was a nice one. I want to thank nearForm because I work there and to some extent they sponsor a little bit of this work. And I want to thank this other company called Let's Do It. It's a startup from one of my friends. They are putting it's in production. They are using Fastify in production. And one of the guys is Thomas de la Vedova, which is the other lead main maintainer or whatever releaser of Fastify. So this presentation is available at these two URLs. Give me 10 minutes so they can upload it. Okay, and there is an old version of this talk. I hope you can check now and check in 5 minutes. So I changed it a little bit for this conference. Yeah, picture time. So again, this is me, Matteo. I write a lot of open source and maintain a lot of open source. Most of the time these days I work on Node Core. So I help maintaining streams. I don't know if you know about that thing, but it's a complex piece of software. I also work in the HTTP2 team. So if you're thinking about using HTTP2 in Node, talk to me because we want your feedback, okay? Then let's say thanks in the sense that if you need help from Node.js, come and talk to us. We are at our booth at the end of the booth lane. So come and talk to us. We are a Node.js professional services company. We can help you if you have any performance or deployment or whatever problem you have with Node and JavaScript, we can help. Now, I have a very important thing to say. So I have a bunch of stickers, okay, which is a very important business in the Node community, okay? So I have a bunch of stickers if you want the stickers. Another thing I didn't talk about was our logger, which is Pino. It's probably the fastest logger out there. If you've gone to Charlie Talks, it was the car with the engine at the top of it. And that was more or less the thing. It's very fast and very opinionated, okay? So if you want to check Pino out, it's this thing here. So you can, if you want to come by and get a sticker, hey, you can, or otherwise, thank you for coming.